Has this ever happened to you? I have a brand new water bottle, and I can see too much of it. A blank water bottle can be an unsightly bore. Luckily, using our patented technology, there is a solution. There is? There sure is. It's called stickers. These incredible devices are covered in glue on one end and funny, attractive designs on the other. They are the ideal solution for any water bottle in need of a little pizzazz. How do I acquire these stickers? Well, fictional customer, I'm glad you asked. Just go to wildgreenmemes.com, that's wildgreenmemes.com, to grab your very own wild green stickers. Wow, thanks, mister. Now what do I do about my fridge? Just wait until we tell this guy about magnets. wildgreenmemes.com.
This is Wild Green Streams. I'm Rhett.
I'm Io.
And today on the show, we have Dr. Brian Fisher. Brian Fisher is chair and curator of entomology at the California Academy of Sciences and has spent 3 decades documenting the island of Madagascar's insect biodiversity. Fisher founded the Madagascar Biodiversity Center in 2004. As he witnessed the biodiversity crisis unfold in Madagascar, Fisher began applying traditional insect-eating practices to reduce bushmeat consumption, sustain forests, and improve nutrition. In 2022, he opened the Edible Insect Lab in Madagascar. Brian, welcome to the pod.
Great to be here. Thank you, Rhett.
So I want to talk about your work more in a minute, but first, you're the subject of one of the funniest ecology memes that I've ever seen on the internet. Do you want to describe the picture and maybe tell the story of what was actually going on during that interview?
Well, that was an expedition to Madagascar to a one of the most difficult places I've worked in. Now, I've been to about 454 sites in Madagascar, and this one would be the only one maybe I would like to eliminate because we had such it was a very difficult place to get to in the northeast of Madagascar. We had enormous complications of logistics, but on top of that, it was during the cyclone season, and we got hit with the cyclone. And as long as everybody has food, there's not a problem, right? But our porters could not return every 10 days to our field site to bring new food because there was a cyclone going on. So after 10 days, we basically had no more food and couldn't get off the mountain because no porters could also help us get off the mountain. So everybody became hungry and grumpy, including our film crew that was there. And so just to liven the situation a bit, I started changing the script a bit. And this was just a script about the giant banana slugs. In a sense, they're not banana slugs, they're just snails that are everywhere. In fact, it's an introduced species from Africa, not native, but they're everywhere in the rainforest.
So the picture itself is, it's you and you have a snail on your glasses on your face, just as you look very professional otherwise and very serious in the picture during doing this interview. And that still frame got taken out and on the internet, other people responded to it. And the funniest comment is someone who says, "Dr. Fisher, you're a scientist. Get off that man's face," pretending that the snail is you.
How many people have seen that? I've given talks around the world, and most people don't know about my other research except for that meme. But anyway, it's a great introduction.
Well, you know, I was actually kind of stunned to see your other research because I also had only seen the meme, and I was actually looking for one of your colleagues on the California Academy of Sciences page because I was going to see if he would do an interview about some of his work. And I just recognized your photo on it from the meme. Started reading more about you and your work and saw that, among other things, you've discovered over 1,000 species of ants.
Well, to be honest, for insects, that's not a hard thing to do, except that those 1,000 new species are from one tiny island of Madagascar. And that's amazing because Madagascar is not... It's like its unique world. It was part of Africa, broke off about 120 million years ago, along with India. Then India, about 80 million years ago, moved north, dropped to Seychelles, ran into Asia, formed the Himalayas. Meanwhile, Madagascar is on its own. And isolation is the number one driver of uniqueness in the world. And it was like its own story. And those organisms that arrived there evolved there, radiated there, including the ants. So the ants you find in Madagascar, 99.9% of them you don't find anywhere else.
And so I believe from what I've seen, there's maybe 22,000 species of ants-ish known to science at the moment. Given that, in a relatively short time, 1,000 new species of ants were discovered just in Madagascar. How many more species do you think there are globally that we just haven't looked into or discovered yet?
That's a good question. We can use estimates of rates of discovery of new ones, but overall, I would say there's probably 30,000 species of ants easily on the planet Earth. And how and who describes them, that's a field of science called taxonomy and systematics. We have great new tools to help us out, but we actually have fewer and fewer people, in a sense, that are able to dedicate their lives for the discovery and description of those new species. So there's no great momentum to describe all those ants. So there's enough for everybody if you're interested. But it's an important task. I am based in California, but work in Madagascar. But even in California, there's a surprising number of undescribed species. It's slow going to describe them. It's meticulous work, but it's important work.
When you get to about 1,000 species, does figuring out new names for all of them get complicated? I imagine if some of them are distinct, you could say, okay, this one is a red one and this one is a black one. But if they're fairly similar, I imagine that picking out names that are distinct can be a little challenging.
That approach, naming them after color or characteristics, is the traditional approach. In fact, the first ants described, Formica rubra or Formica nigra, where there's like the red ant, the black ant, that was it. But finding new names is not hard at all. But what that name means has significance for the people where that species is found. And there's a tradition, for example, of maybe Europeans going to a tropical country, exploring, finding new species, and then they name it after all their buddies. And then the people of that country may have names that have no relevance. And I do think it's important to treat that name as an honor, to give it a name and actually choose it wisely. And for me, that means it's at least represents something that the people in that home country would be proud of or support.
I like that a lot. That's really cool.
Yeah, I think that is too. Two-part question. Do you have a favorite kind of ant? And also, do you have a favorite ant name?
I like many, many ants, but it's true, not all ants are as cool as the other ants. I like a lot of the ants that are predators, that have evolved unique mandible shapes or unique adaptations to get food out of a little tiny microhabitat. There's one genus called Strumigenes. That's a trapjaw ant. That means its mandibles snap shut really fast. And I described about 70 new species in that genus alone for Madagascar. And in one of those species, I named after, using a Malagasy word for ancestor, Bazimba. And it was the largest species. So it's because the Malagasy really think ancestors are important. And elders are important for that same reason. And that symbolizes the importance of respect. So in respect that I'm not Malagasy, but describing those ants, I named, I think, the most beautiful one, Bazimba.
Sure. What led you to work in Madagascar specifically?
That's a bit of a long story, but I'll try to make it short. I didn't initially want to think I was going to work on ants. I was going to work on plants. And I went to undergraduate, kind of pre-training myself to be a botanist, and I knew I wanted to be a tropical botanist, and I sought opportunities to work in tropical botany and had a chance as a sophomore, my second year, to go to Panama, to Barro, Colorado Island, and spend 9 months. So I took off the whole year. And there I worked with all these great botanists, traveled around to the highest mountains and came back with plants. And basically, they had a great reference collection of all the plants, and they could put often a species name on the plant I collected. But in the tropics, what surprised me were the ants. They were everywhere. They were like dust falling down from the sky. They were just everywhere. And I kept asking people, what about these ants? And they said, oh, we don't know anything about the ants. Where's the book? There is no book, and there is no key. And right then I decided to switch from working on plants to working on ants.
How did you get from ants to Madagascar specifically?
So I just switched to ants, working as an undergraduate with these great botanists, and felt what they were doing for plants and birds, I could do for ants. I wanted to do for ants. And that is, at the time, I was introduced to people like Robin Foster and Al Gentry, who were botanists that were formed this group called Rapid Assessment Program, where they would get flown into an area, an unexplored tropical forest. They'd go in there and they would be able to document the uniqueness of that patch of forest or that mountain. And they could justify why that forest could be protected based on the uniqueness. And I said, well, ants are so important. We should be able to do that just like we do it for birds and plants. We should be able to do that for ants. So I started with this idea that I could do it where I've trained in Central America or South America, and started a project in Bolivia, an NGO called Tracks with colleagues to explore biodiversity and create national parks. But I quickly realized we know very little about ants along the Andes in the rainforest. And to be able to assess one location, I would have to know a lot about the entire region or bioregion or subregion. And that would take a lifetime. So to do my PhD on that topic, I looked on the map and said, oh, Madagascar is so small. I bet for my PhD, I could just go there, demonstrate how we could do rapid assessment design, inventory, analysis, and justification for using ants, and then go back to South America. Well, that was in 1992. I started it. For 30 years, I've been going to Madagascar, and I'm still discovering new species and actually learning how to evaluate diversity patterns. And we can talk more about that. That was a journey. So I've been on this journey of discovery in Madagascar about how one can do biodiversity exploration. And my goal has always been to be able to use that data for conservation. And that's been the long-term journey and urgency, I think, for Madagascar. And I had to give up working in a lot of places to make this happen in Madagascar, but in the end, I'm glad I did.
And for all of those species, most people, especially, in more urban areas, don't really think of ants. They're sort of a pest, don't really pay any attention, and wouldn't really think that there's this much diversity. But for this much diversity, how have they been able to evolve into fill all of these niches? It's sort of like, what are they all doing differently? What are some of the different niches that they have evolved into that is like, okay, this is a place that we could sort of take advantage of and become so different?
That's a great question. And evolutionary wise, one could ask, why have ants diversified so much? And we can look at the numbers. So in terms of numbers, ants, let's say there's 30,000 species. If you look at insects, that's not such a huge number. There's probably 50,000 weevil species out there, right? But we don't talk about the amazing abundance of weevils, right? Because the sheer numbers of the biomass of weevils is much less than that of ants. So ants have not just become diverse, they become super abundant, and that makes them at times really important, especially for tropical systems, to be part of that. And you're right, most people don't see that. We're talking not just tourists, we're talking about biologists. When you go into a forest, you may be more impressed by the big trees, all the large animals, anything that looks pretty. And we forget about what's behind that system, the Brown cycle, the turning over of nutrients, in which insects rule, the connectivity in a network, the glue that holds the individual nodes together. That's the individual nodes are the species, but all those connections, they're often driven by insects. So that network, that glue of connectivity of a rainforest is the super important part, and ants dominate that in so many ways. You could probably remove birds from the network, right? And the network would still function.
Those are fighting words. Yeah.
Yeah. But you could remove the insects, right? The insects are so critical, and ants network systems are some of the most dominant ones. And in many occasions, of course, above 2,000 meters in elevation, there are fewer ants. In deserts, they're at some super 12-month dry season, there are fewer ants, but in most of the tropical systems, ants really dominate in terms of biomass, diversity, and function, different types of networks that they are important in.
Even though it's smaller than a continent, obviously, is Madagascar comparable in biodiversity to other continents, like, say, to Australia?
Well, if you look just close to Madagascar, which would be Africa, if you look at a region, you would find similar levels of diversity of ants too in Africa, Congo Basin, compared to a spot in Madagascar. But what's different is the species are completely different. There's no relationship, and also what's in Madagascar, it didn't for ants and most life arrived by dispersal. So they didn't go for the ride when Gondwana land broke apart, when Madagascar separated. All the ants that were on that ride disappeared in the K2 boundary, which was devastating for a lot of insects, including like almost all ants. Very few ants survived the K2, so around 60 million years ago.
So that's the asteroid that hit the Earth and killed the dinosaurs.
Correct. And so those that are there now in Madagascar arrived there by dispersal. And those are just chance dispersal events. And those that arrived diversified into amazing things, which is a great story, but that's a hidden story. And I look back on my work in Madagascar. When I first went there, I took the knowledge of ants that we had for Africa and kind of placed everything I collected in Madagascar into that knowledge. So major lineages, the genera, and other subgenera, we could say. We just kind of pigeonholed, it must go here, it must go here. It took over the last 10 years, really, through molecular work to realize that for ants in particular, we have a story of convergence, where ants can seemingly evolve to do similar things very easily in different continents from different origins. And they may look alike so much that you'd place them in the same genus or even the same subgenus, because they look so much like the ones doing the same thing in Africa. And it's been a real interesting story that place actually rules everything. I played place, it's one bioregion. So you should always question when these lineages cross biogeographic boundaries to make sure it's been tested phylogenetically, because convergence is a real issue. And that also means through this molecular work that we've discovered basically how many times ants kind of arrived to Madagascar, and we see repeatedly these giant radiations. Even for like the carpenter ant, where carpenter ants are divided into many, many, many subgenera, and the ants of Madagascar were placed in many, many subgenera. But in the end, we're talking about 3 arrivals and 3 radiations of Camponotus on the island for all 120 species on the island.
Wow, that's fascinating.
That is cool to think that ants arrived multiple times to Madagascar. It wasn't just one, and then, then they all took off from there. There was multiple introductions, and then from there, because that would be so interesting. It's not just one, all right, then done, go set it off. It's, all right, you're just going along, and then, we have another introduction. Do you know if species that were later introduced were, there's, the first wave, so you say ants A, B, and C introduced, those ants later turn into ants 1, 2, and 3. If there was, during a second wave, ants A came back again, but ants A has already turned into a different species. Do you know if that has happened, or is it tricky to tell?
Well, for it to be here now, it's when extinctions happened or failed arrivals, it's hard to get that out of the record. But we can look at things that arrived, and we see some interesting patterns. Though this week we did just publish with colleagues, great colleagues, on the biogeographic patterns of ants of Madagascar using a UCE, that's a ultra-conserved elements, a phylogenomics approach. So we've sequenced and created a phylogeny of all ant species of Madagascar. This is the real first insect approach to the phylobiogeography zones of Madagascar. And we are next exploring more details about diversification, where you have, at certain older periods, dispersal from Asia arriving, and I'm just generalizing, and more recent arrivals come from Africa. So which of those lineages hold the most diversity and range in Madagascar? Like which are the dominant groups? If you're older, do you have more chance to radiate and therefore dominate the diversity? Or is it the newer ones that radiated more quickly? So these are all these interesting stories we're trying to piece apart, because not all arrivals resulted in radiations. Some are like stagnant, or maybe they went all extinct. We don't have records of them, but it's super interesting to explore.
It's something that occurred to me. Is the reason why the older arrivals were mostly from what's now Asia and the newer ones are from Africa because India was closer to Madagascar at that time than it is now?
I wish we knew the answer to that, because we unfortunately don't have a lot of genetic data for the species in India. Biodiversity issues don't have borders, but science is done locally, and science has borders, and it's been difficult to share specimens out of India for sequencing. So one day we'll be able to go to India, work with colleagues, and sequence all the ants there and share the data, hopefully. But right now we haven't been able to include those species. But older specimens took advantage of the fact that long ago there were currents that favored dispersal floating from Asia. So possibly they rafted there, while more recently there were currents more coming from Africa. So that could explain it. Or there could have been land bridges that were present from India to Madagascar. That's another hypothesis.
Sure. You mentioned that you've taken a heavy tilt towards applying your research and your work towards conservation. You want to talk a little more about that? I know that you have a lot of work involved in sustainable agriculture, including with insect agriculture. Yeah,
it's been real exciting change. It stemmed from about 2016, 2017. We started noticing that when we go back to a field site, in fact, it was to collect one of these lineages that we think is, at that time, we thought it was from Asia. Very strange ant. Unlike all the African ones of this genus, it's a Anacetus that looks kind of like the ones from Asia. So we wanted to collect it to sequence it. And it was known from one mountain site. And we went back. This mountain is pretty interesting. You have to climb up this steep ridge, and you get to the top, and it's a plateau of beautiful forest. So we went back, we hike up, after a day, we clear the edge, and we look out, and every tree was gone. It's just devastated. There's no trees left. They cleared the whole thing for farming. And that was sad, and there goes that species. We since found it in another spot nearby, but that's it now. And we felt that, I began to feel all our work to document ant diversity has done little to preserve any forest in Madagascar. The way taxonomy works, we kept saying that each collection would help us understand biodiversity and thus help save biodiversity. But in the end, I don't think that really happened. One, because I think taxonomy, in my case, has been very slow. We haven't been able to synthesize and make concrete conclusions to help biodiversity planners. And it's often, as an entomologist, we can say that, oh, we're not really, we don't really have to have any kind of social responsibility that way because we're doing basic science. And I began to realize that maybe it was just an excuse to not get involved. So I said, okay, look, what could I change in the way I work that could have a bigger impact? And it just became obvious what I had to do. One, for our inventories, clearly our 450 inventories have produced a lot of specimens, and in the next 100 years will produce a lot of new species. But in terms of short term, very little. So what if we could change it in a way to have some short-term benefits? And instead of inventory, we started a program for monitoring. And right now we have 53 parks and sites with our team. The group is called Life Plan, based out of Finland and Sweden, where we actually have semi-automated traps that sample weekly. We have malaise traps that we use metabarcoding to identify and cluster all the specimens that are collected each week in each of those 53 sites. We have cyclone sampler that samples fungal spores twice a week. We have audio moths that use AI to identify the birds. We have camera traps for vertebrates and lizards and mammals. And we can actually get data into the hands of the national park system and even mining companies that do reforestation, on a weekly basis. They don't have to wait for the every 3-year taxonomic publication to find out if they have a new species there. They get actually kind of like a Dow Jones index to the environment on a weekly basis. And we still get new data on ants. So to me, I'm still getting exciting data weekly now on ant diversity, phenology, diversity patterns, what's new. And so I feel like it's augmented our ant research in a real critical way. But at the same time, we've learned more about insect diversity as a whole in the first year of our sequencing than we had in the last 250 years of research in Madagascar about overall insect diversity, what's there, and patterns about it. And also, we wanted to say, okay, that's great for monitoring. I think that justifies biodiversity exploration. But what about forest loss? Is there something we can do? And we realized you can't have forest when the people living nearby are hungry. And of course, what would I have to contribute there? But then it just hit us that edible insects. So we began researching edible insects on the island and found that Madagascar today, 70% of the people still eat insects. There's 130 species of insects they eat. And what if we could actually leverage that tradition to provide and encourage insect farming in villages and at larger scale to provide nutrients or address malnutrition, but at the same time, use those insects for small farmer feed, like for chickens and pigs and tilapia, and also use the byproduct of farming, which is called frass, as a super fertilizer to bioactivate that soil. Because the lack of fertilizer, in a sense, is in poor soils is why they cut down the forest, burn it. That's the only way to get a boost of fertilizer in the system. So we have this incredible program that we call Small Farms, where we teach and learn and monitor black soldier fly farming across Madagascar. And we actually are developing a large-scale farming of crickets to actually develop snacks, our insect cracker, for school lunch programs in areas that are most needed in Madagascar.
How do the crackers taste?
Well, it's funny. We made it super tasty in the beginning, but our partners decided that it was too tasty, and the kids won't eat it. They'll take it home, and the parents will sell it. So we kind of only have a one spice, and it's great. If you put a big bowl of them, it's like Cheetos with less flavor. If you put it in front of you, you'll eat it, but it's not as, your fingers aren't as dirty afterwards.
I guess if it has resale value, you did a good job.
Right, but we have just finished some great acceptability studies with our partners at Cornell, Wisconsin, and Path, and there is no acceptability issue with our products because I think because insects are just part of the tradition in Madagascar.
That's interesting. I think this is a really brilliant program. This sounds amazing. What are the traditions in Madagascar around eating insects like? Are there particular groups of insects that are, part of the cuisine or?
During COVID, I did a deep dive with a colleague into all the literature that ever existed, published on Madagascar, back 400 years to look for any other recipes and mentions of insects eating in Madagascar. And it goes back to the first publication. And they were surprised early on that Madagascar really didn't have any famine issues. Why? Mostly because of Orthoptera. These are the locusts, katydids, and crickets, grasshoppers, where during that moment of plenty, like an outbreak, they would gather them up, the locust or the grasshoppers or the crickets. They would dry them they would boil them, dry them in the sun, grind them into a powder. That powder is stable. They can keep it, and then when they need it, they can actually add it to their staple, which is rice. And that replaces, any other protein source that they would have throughout the year. So when the lean time during the farming season, they could add that to their rice. And people commented for many, many years about this. Now, things have changed now, where there's a lot more people in Madagascar. Now, they spray pesticides on the locust, so you can't eat it. And in villages, they still gather up it locally, but in the large cities, they don't really have access to a lot of edible insects. But if you do find people eating it now, it's exact same recipes they were using, that we'd shown they were used over 400 years ago.
Mm-hmm. Well, Brian, I want to be respectful of your time. We could ask you questions about this for hours, I feel like. I see how that other interview went for 2 hours, but do you have anything in particular that you want to plug today before we do the sign off?
Well, I love these questions. I think my journey in science has been from exploration to saying that as a basic scientist, we can also offer solutions. And that new journey of solutions has been just as exciting as my first trip to go to a forest in Madagascar where I didn't know what I was going to find. And I poured the ants into a petri dish and came to the microscope and just was amazed at all the new genera to list from Madagascar on my first trip. And the journey of a scientist is, I think, the most exciting life one could have, because it's like always learning something new. To be a scientist means you're always learning, and the journey never ends. And it's been very great to spend 30 years, and I hope I have another 30 years to dedicate to the work in Madagascar.
Where can people go to learn more about your work?
MadagascarBio.org tells you about all the programs we're doing on diversity discovery, monitoring, and the edible insect program.
That's our show. Thanks for listening. You can power the pod and get cool merch in the mail at patreon.com/wildgreenmemes. That's memes with an M. Until next time, I'm Rhett.
I'm Io.
And I'm Brian.
And happy Year of the Frog.